Hello again, this is Alister McGrath introducing another short presentation on issues in science and religion. And again, these are just sketch maps of a very complex landscape. I'm simply trying to flag up some issues, give you some pointers to help you develop these issues further in your own time using your own resources. Now in this and the next talk, I want to explore the widespread use of models, analogies and metaphors to help us grasp complex realities, whether we're talking about science or Christian theology. And in many ways, the issue here is how we go about developing mental images of unobserved entities. We try to understand them and then to figure out ways of exploring them further. Now, in everyday life, we often use analogies to help us to think about complex matters. We find it very easy to say, well, it's a bit like this or that, meaning that the image that we are suggesting is helpful in some ways, but not necessarily in others. In other words, we're talking about similarity, not identity. It's a bit like this, but in other respects, it's not like this. And the key question is to explore the extent and the nature of that similarity. Let's begin by thinking about the use of analogies and models in the natural sciences. And the natural sciences use these analogies and models all the time to help us understand complex systems. A very good example is the British physicist Ernest Rutherford, who in 1910 developed a simple model of the atom as a miniature solar system. And you've probably seen this image of the atom in popular science programs and publications. Rutherford suggested we think of the atom as having a very dense nucleus which was orbited by electrons in much the same way as planets orbit the sun. Now the key point here is that the atom is not solid. It has vast expanses of empty space. Rutherford's model was very easy to understand, and it offered a theoretical framework that explained most of the known behavior of atoms at this time. You see, before Rutherford's famous scattering experiments, scientists thought of atoms as solid lumps of matter. And Rutherford's experiments showed that there were vast expanses of empty space within atoms. And his solar system model of the atom was designed to help us visualize a very dense core to the atom with a lot of empty space in which electrons orbited. So you can see, I think, that this is a very helpful way of thinking about, and it corresponds in many ways to the general use of models in the natural sciences. The philosopher of science Peter Godfrey Smith, for example, suggests that the scientific use of models is all about developing deliberate simplifications to make complex systems easier to grasp. Here's what he has to say. Our model is an imagined or hypothetical structure that we describe and investigate in the hope of using it to understand some more complex real-world target system or domain. So scientific models are clearly useful in helping us to visualize a complex or indeed an invisible system. But I think we can make two serious mistakes when we use models in the natural sciences. First of all, we might think that models are identical with the systems we're modeling. And that's clearly not right. The atom is not a miniature solar system. Rutherford's model of the atom merely points out that we can understand some features of atoms if we think of them in this way. It's a helpful analogy. It's not an identity. And the second mistake also arises from this fact we're talking about analogy, not identity. And the second mistake that we can make is to assume that every aspect of the model has to be present in the system that's being modeled. But again, the point to appreciate is that analogies and the systems we're trying to represent resemble each other in some ways, but not in every way. Atoms are like miniature solar systems with orbitals, electrons orbiting the central nucleus as if it were a sun. But you see, it's not quite like that, because electrons are not located in definite orbits like the planets. They're delocalized. But you can see how helpful the analogy is, providing you don't press it too far. Or again, we might go back to Charles Darwin's famous book, The Origin of Species, published in 1859, which we looked at earlier. As I emphasized, Darwin's genius did not lie in showing that biological evolution actually took place, and this was well established by that time. His contribution was really about identifying the mechanism that lay behind it. And Darwin proposed natural selection as the process that lay behind the phenomenon of biological evolution. Now, natural selection is an analogy. It's a model. And it's, in effect, a model that's developed from the idea of artificial selection. If you look at the first chapter of The Origin of Species, you'll see that Darwin is very, very clear. You begin by thinking about artificial selection, the way in which professional stock breeders and market gardeners created new forms of domestic livestock and plants. So that is what you're beginning from. It's a process of creating new breeds. And Darwin's argument is that a process comparable to this, which he called natural selection, took place within nature itself over extended periods of time. It was analogous to artificial selection, but clearly not identical to it. Now, the point I must emphasize here is that natural selection is not something that Darwin observed. It's something that he inferred from what he did observe. So basically what Darwin is saying, there's a process called natural selection that takes place in nature over extended periods of time, which is analogous to the process used by stock breeders or market gardeners to produce better plants. It's an analogy, but the analogy raises a very serious problem, because Darwin's phrase natural selection seemed to many of his readers to suggest there was some kind of conscious process of selection taking place within nature. In other words, nature selects. The analogy seems to imply that the active selection on the part of the animal breeder in artificial selection is paralleled within nature itself. So nature is selecting certain forms of life in this process. And here I think many would say that Darwin's analogy is being pressed too far and thus being misunderstood. But Darwin, in effect, felt that this was an appropriate analogy and did not understand it to mean that nature actively selected. It's simply a way of understanding the process and working out how it functions. So we looked at some uses of models and analogies in natural sciences, looking especially at atoms and natural selection. But what about the place of analogies and models in religion? Let's look at this in the next presentation. Thank you so much for listening.